What is permutation combination? So see, both permutation and combination, both are combining. Okay, what you said, creating set, right? So both are creating or choosing, okay, or selecting R things from N things. Okay, both are about choosing R things from N things. Okay, both.
Okay.
What is different is, okay, in your P, okay, OP, P, okay, order matters. Okay, in permutation, order matters, and in combination, so both permutation combination is about choosing R things, okay, from N things, choosing 5 from 10, right? Both are about forming combination. Difference here is that in permutation, order matters. Okay, the way in which you put order is important. Okay, in combination, order doesn't matter. Okay, so you have two main thing, right? Where order matters, order doesn't matter. Order doesn't matter is combination, where order matters is permutation. Okay, then you have something called as replacement, with or without replacement. And here also you have two cases, right? So this will have two cases. Okay. Oops. No. Two cases, with or without replacement. Okay. Here also you have two cases, with or without replacement. Okay. You have two cases, with or without replacement. Now what happens in first case? Okay. Now you tell me. Okay. Before we get into formula, which one out of permutation combination will be a smaller value and which one will have a larger value? Where order matters will have a larger value, or where order doesn't matter will have a larger value? Simple logical question I'm asking.
Sir, can you repeat, please?
Okay. So the total answer, let's say, I have to choose 5 things from 10 things. Okay. I have to choose 5 things from 10 things. Permutation will have lower value or combination will have lower value?
Combination will have lower value.
Combination will have lower value. Where? Why?
If it doesn't, or that doesn't matter in combination.
Right. So let's say if I'm saying that I'll toss a coin 2 times, what is the probability of getting? If I toss a coin 5 times, probability of getting 2 heads. So when you say 2 heads, for example, now in combination, order doesn't matter. So head is same, or let's say 1 head 1 tails, for example. So whether it is head tail or tail head doesn't matter. Order doesn't matter, isn't it? Whether you put head first and tail next, or you get tail first and head, it doesn't matter. So 2 option will become only 1 option. But where order matters, head, tail, head, and 2 different combination, right? So same value, same thing we are counting 2 times in permutation, right? So permutation will have a higher value, right? So what is the formula of permutation? Okay, NPR we call it, right? N combine N total items, R we need to pick. So the P is, okay, N factorial by N minus R factorial. Combination, since it will be less, so we say N factorial by N minus r factorial, okay, and then you divide again, right? So that means you are putting this in a bracket, r factorial, okay, n factorial by n minus r factorial is b. C, as you said, c will have a lower value, so we put divided by r factorial. P factorial, P permutation divided by R factorial is your combination.
Okay, sir.
Okay. Now I'm going to ask you a question. You tell me whether it's a permutation problem or combination problem. Okay. In a group of let's say 6 boys and 4 girls. So we got 6 boys and we have 4 girls. Okay. I need to select 4 students. Okay. So what is, how many combinations and permutations are possible? Okay, so make it simple first. Then we'll go to boys and girls. Let's say I have 10 boys, 10 students. Okay, I have 10 students and I need to select 4 students. Okay, how many combinations are possible? Is it a permutation problem or combination problem?
Combination.
Combination.
Combination?
Yes, sir.
Why?
Order doesn't matter here, no, sir. Like
Order doesn't matter, yes. The 4 students I need, right? So it can be any 4 students, right? So here order doesn't matter. So this will be your
combination problem.
combination problem. Okay. Then we'll solve later using Python. Okay. Now, okay. So let's say I've got I've got 4 coats. Okay. 4, 3 hats. Okay. And let's say 2 umbrellas. Okay, I've got 4 coats, raincoat, 3 hats, and 2 umbrellas. Okay, how many combinations can I use them to wear these? Is it a permutation problem, combination problem?
Permutation.
Why?
Here we have different items, no, sir. Order matters, no, sir.
So coat with one hat and same coat with other hat is a different combination.
Yeah.
So order does matter, which order I'm using. Okay.
Yes.
Okay, if I change even one, it changes, right? So order does matter. So we have something called as SciPy. Okay.
Okay.
And SciPy is an advanced version of NumPy, you can see. Okay, scientific. Okay, that's what the SciPy stands for. Scientific. It has a lot of scientific functions. Okay, all the mathematics and electronics formula that you can think of can be solved using SciPy. So we have something called as SciPy Special. Okay, so from SciPy dot special import. Okay, so import you have perm, which is permutation, and you have combination. Okay, so I'm going to do one problem, and then your task is to find at least 3 to 5 permutation problem and combination problem from your maths book and solve using Python.
Okay.
Okay. So how does it work? So if I have to find, let's say we'll try to solve this problem first. This is which problem? Combination problem, right?
Yeah.
So your output, okay, our result is going to be combination. So you see here, the moment I type B here, right? So you say N, K. So N is the larger, how many out of K? And you have other things, we'll see one by one. So, okay. So combination, I have 10 students, correct?
Yes, sir.
And to select 4. Correct? So using this formula, combination formula, no. Yet, so first one is 10 students, right? This one we are trying to solve, isn't it? So this is what we said is a combination problem, correct? So if you solve manually, what is the value? N factorial is 10 factorial by 4 into 6 factorial. So 10 factorial by 6 into 4 factorial, which is R, right? And N minus R factorial, right? So you can write 10 factorial as 10 into 9 into 8 into 7 into 6 factorial. So your 6 factorial and 6 factorial get cancelled out. And 4 you can write as 4 into 3 into 2 into 1, right? So your 4 into 2 is 8. So 8 goes cancelled. This you have 3. So you have 30 into 7. 30 into 7. So what is the answer?
321, 210.
210, right? Now let's run this and see. Print result. Okay. 210, right? Yes or no?
Yes, sir.
Okay. Now let's modify this question. I have 6 boys and 4 girls. I need to make 4 students I need to take. So how do I solve it?
It's a permutations problem.
Mm-hmm.
So we have to go for same, sir. Result equals to comp 10,4. No, now we'll go for perm 10,4.
It is combination only, no order doesn't matter.
Refresh me.
That's what you said.
It's permutation problem, sir. Order matters.
Oh, you only said order doesn't matter. How can you say
Sorry,
order matters?
I forgot by mistake, sir. It's a permutations problem. Order matters.
It is combination problem, not permutation problem. Okay.
6
Let's
boys
say-
and 4 girls, no, sir.
Wait. Hold on.
4
Okay,
boys,
so
0
let's say,
girls.
right. So we have 2 boys and 2 girls, right? Pujita
Okay.
and Nikki, and you have Dwanit and
Karthik.
Karthik.
Yeah.
So if I want 1 boy and 1 girl, if I
Okay.
pick Dwanit and Nikki, it is still same, right? Whether I pick Dwanit first, Nikki second, or Nikki first, Dwanit second, does it matter? No, it doesn't matter.
Okay.
It's still the same thing. So
Yes.
order here doesn't matter in such
Okay.
kind of problem. You won't, the value, the answer will not change. You cannot, it's like, you say that, okay, I want one person to stand for election. First person stand. Then you say, no, I don't want this guy, I want somebody else. Then again, same person comes. Why? No, I'm number 2. Earlier I was number 1, no, I'm number 2. No, it doesn't matter, right? Same
Okay.
person is same. So this is still a combination problem. This is not a permutation problem.
Okay, sir.
Okay. So how do we solve such problems? So
Sir,
such
first with
problem,
4 boys, 0 girls.
correct. So
Sir,
such problems you cannot, yes, you cannot solve in one step. Okay. I need 4 students, right? So I can select multiple cases. First case is all 4 boys, correct? And 0 girls. Second case is 1 boy and, or let's say 3 boys. Let's decrease 1 by 1. 3 boys and 1 girls. 1 girl. Then 2 boys and 2 girls. Then 1 boy and 3 girls. Then 0 boys and 4 girls. These are the total possible combination, right? So now, how do we solve it? Case 1, C1 equal to combination 4 boys and 4 out of 4, right? No, 6, right? Sorry, 6 boys, right? So N is 6, R is 4 plus, 0 girls. So 0 girls is 0 into, right? So that's the only case 1. Yes or no?
Yes, sir.
Okay. Now, second case is combination 6 boys. Out of 6 boys, I need 3 boys, and then combination, okay, out of 4 girls, I need 1 girl to make it a committee of 4 members, right?
Yes, sir.
Okay, then C3 equal to
6,2, 4,2.
right. Right?
6,1, 4,3. Yeah. And that is whole set considering, sir. 4 girls.
So now 4 girls also, right? One more I have to do.
4,4.
4 comma 4. Okay, C5 equal to 4 comma 4. Okay. Now condition is it should have at least 1 boy. Then this is not true. Correct? You have to remove this.
Yes.
Now if I tell you number of boys and girls should not be same. So
C3 should be removed.
this should be removed. Exactly. And what is the total answer? Total answer is C1 plus C2 plus C3 plus C4 plus C5.
C5. Okay.
Okay. So this is the total answer.
Okay.
What if repetition is allowed? Then you have a function here called repetition. You say true. By default, repetition is false. If repetition is allowed, just make it true and you don't have to do anything else. Okay.
Okay, sir.
So in combination, okay, we are saying or, right? Either this or this or this or this. When you use or, you add. This is also possible, or this way can do, or this way, or this way. Now let's take the other example. I've got 4 coats and 3 hats and 2 umbrellas to wear. Carry or wear, whatever you call it. Okay. And okay. So let's say there are 2 men who wants to wear this or carry this. Okay. So let's say, 2 brothers, and these are the things that you have. 2 brothers have to go out in the rain. Right? What are the total? Okay. It is a permutation. Order matters, right? What is owned by first brother cannot be owned by second brother. Right? Same thing can be owned by second brother. So here order matters. Isn't it? So this is a permutation problem. What is the permutation here?
Like for one man, it is just combinations. When it is coming to 2 men, it is becoming permutations.
Correct. So now in this example, in your first case, okay, you have permutation, right?
Yeah.
So 4 code can be owned by 2 brothers, right? Okay. Second case, okay, you have 3 hats owned by 2 brothers. Two umbrellas were born by 2 brothers. Okay. And now it is combination, right? So you have to multiply all this. The result is going to be C1 into C2 into C3. This is your, okay. If repetition is allowed, you will say
Equal to true.
okay. Now you see in combination, the repetition is not, the repetition value itself is not there. Okay.
31st line result is equals to, sir.
Oh yeah. Okay. So this is your answer. This is how you have to solve combination problem.